So this is going to be E3.3, which is locating real zeros of polynomials. And here's our instructions. Use each given zero to make a polynomial factor, multiply out all the factors, and then write it in function notation. So when we're given -1, 0, and 4 as our zeros, what that means is that we ended up with x equals -1, x equals 0, and x equals 4 when we solved, okay? So if we got those values when we solved, that means we had to have had an x plus 1 equals 0 as one of our factors. Here, if I move 0 over, I still just get x equals 0, right? And here, if I move 4 over, that means x minus 4 would have had to be one of our factors. So all I'm going to do is multiply our three factors back together, and I'm going to call this polynomial function p of x. Okay, so I'm just going to bring back together all three of my factors. Okay, so I have x times x plus 1 times x minus 4. I always write the single monomial factor out front. Okay, if you didn't do it that way, you should still get the same answer. Okay, so this is my polynomial function that gave me these zeros. Now all I have to do is FOIL it all out and distribute it in combined like terms. So I'm going to go ahead and FOIL out these two, and then I'll distribute my x in. Okay, so I have x times, when I FOIL here or distribute, x times x is x squared, x times -4 is -4x, 1 times x is x, and 1 times -4 is -4. So I'm going to go ahead and combine like terms, so I have x squared minus 3x minus 4, and then I'm going to go ahead and distribute that x, and I'm going to move up here because I ran out of room. Okay, so I have p of x is equal to, when I distribute x times x squared, I get x cubed, x times -3x is -3x squared, and x times -4 is -4x. So this is the polynomial that gave us those zeros. So notice we're kind of working it backwards. Usually we're given the polynomial and we factor it and we set each factor equal to 0 and we solve. This time they're giving us the solved answers, so we move it back across the equal sign to get our factors, and then we remultiply our factors to get the original polynomial. Okay, let's look at another one. On this next one, our zeros are 1 plus 4i, 1 minus 4i, and -1. So that means that we had x is equal to 1 plus 4i as one of our solutions, x is equal to, positive 1 minus 4i as a solution, 1 minus 4i, whoops, I keep making marks here, and we had x equals -1 as a solution. So just like before, I'm going to take these answers and move them back across the equal sign. So on this first one, I need to move that 1, which is going to make it negative, and when I move my 4i across, it also becomes negative. Okay, so this here is going to be one of my factors. Same thing over here. If I move my 1 over, it becomes negative. When I move my -4i over, it becomes positive 4i equals 0. So here's another factor. And then my last one, when I move this -1 over, it becomes positive. Okay, so I have all my factors. Okay, once I have all of my factors, then all I have to do is multiply them together. So I'm going to go ahead again and just call this p of x, because we're talking about a polynomial function. And my p of x is the same as x minus 1 minus 4i times the quantity x minus 1 plus 4i times the quantity x plus 1. Now, to make your life easier, I will give you a little hint. Anytime you have factors that have i's in them, you always want to multiply those together first. So I'm going to go ahead and distribute these. Distribute I factors first. Okay, and I'm going to move over here just so that I have some room to do that. So x minus 1 minus 4i times x minus 1 plus 4i. Okay, so when I start distributing, when I distribute my x times x is x squared, x times -1 is -x, x times 4i is positive 4xi. Okay, and I'm going to distribute my 1, and I'm going to write these in columns so it makes it a little bit easier. If you want to write it all out as one list of terms, that's fine. All right, so now I'm going to distribute the -1. So -1 times x is -x. -1 times -1 is positive 1. And -1 times 4i is -4i. Okay, then I'm going to distribute the negative 4i. So negative 4i times x gives me negative 4xi. Negative 4i times negative 1 is positive 4i. And negative 4i times positive 4i is negative 16i squared. Okay, so I'm going to go ahead and draw my line and combine straight down. So I have x squared, negative x and negative x gives me negative 2x. Here my 4xi's are opposites, so they cancel. I have plus 1. My 4i's are opposites, so those cancel. And I have minus 16i squared. Now remember, I squared is the same as negative 1. So I actually have x squared minus 2x plus 1 minus 16 times negative 1, which makes that 16 positive. So x squared minus 2x plus 1 plus 16 gives me x squared minus 2x plus 17. Okay, so that's what I got when I distribute my two I factors together. So I'm just going to write it here. So I have x squared minus 2x plus 17, and then I still need to multiply it times this other factor I had over here of x plus 1. Okay, so I'm going to go ahead and distribute, and I'm going to distribute the small binomial into the trinomial. So I'm going to distribute the x first. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times 17 is positive 17x. And then I'm going to distribute the 1. 1 times x squared is x squared. 1 times negative 2x is negative 2x. And 1 times 17 is 17. Okay. So I go ahead and combine my like terms, which gives me my new polynomial, or my original polynomial, rather, which will be x cubed minus x squared plus 15x plus 17. Okay. So we take our zeros, we make them factors, and then we just multiply our factors together to get our polynomial function. Okay. Anytime you have i's, always multiply the I factors together first. Makes life a lot easier. Okay. All right. So there is one for y'all to try on the next page. I'll give you a few minutes and then we'll go over it. All right. So on this practice problem, we're given the zeros negative 3, 2i, and negative 2i. So when we write those as factors, we should get x plus 3, x minus 2i, and x plus 2i. So now we just need to multiply all those together. I multiply the two I terms first, which I did over here to the side. Okay. When you replace your I squared with negative 1 and simplify, you should get x squared plus 4. So when I FOIL these two quantities, I'm left with just x squared plus 4, and then I need to multiply that extra factor on, which was x plus 3. So when I FOIL those two, I end up with x cubed plus 3x squared plus 4x plus 12. Okay. All right, so let's go ahead and move on. What we want to do next is figure out how to find the remaining zeros of a polynomial. And we do that when they're given us one of the zeros. So they say, hey, this number right here, this is a 0. How do we find the rest? So here's our process. We use synthetic division and the 0 that they gave us to do a division to figure out what our missing factor is. Okay? And then once we find our missing factor, then we can factor it or use quadratic formula to solve for the other zeros. Okay? So let's just go ahead and work one. So on this first one, they tell us that the given 0 is 1. So remember, with synthetic division, that means I put 1 in my box and I write out all my coefficients. So my coefficient of my x cubed is a 1, coefficient of my x squared is a negative 1, coefficient of my x is a 1, and my constant is a negative 1. So I bring down my first one. 1 times the 1 in my box is 1. I combine down and get 0. 0 times the 1 in my box is 0. I combine down and get 1. 1 times the 1 in my box is 1. I combine down and I get 0, which is good, right? We needed to get 0 in order for it to be a factor. Okay? Yay. So remember, this is our remainder. This is our ones unit, okay, or our constant. This is our x term. This is our x squared, which means that when I have this f of x function, it is the same as my remaining factor here, okay, which is x squared plus 1 times the 0 that I used. So the 0 that I used, if I wrote that as a factor, okay, this is x equals 1. So as a factor, that would be x minus 1. Okay. So all I have done is rewritten my function as the 0 that they gave me in factored form times the remaining factor. Okay, so I already have solved this one. I already know this part will give me a 1, but I need to solve this remaining factor. So x squared plus 1 equals 0. I move my 1 over, x squared equals negative 1, and then I just take the square root. Remember, when you take the square root, you have to do plus or minus, which gives me x is equal to plus or minus I. Negative under a radical becomes I. Square root of 1 is 1, so I just get plus or minus I, which means that my zeros for this function would be the 1, which is the one that they gave us, and then negative I and positive I. Okay, let's look at another one. Take the 0 that they give you and use synthetic to find the remaining factor. Now I had a typo on this one. Your notes may be correct, but this 1/3 should be positive, not negative. Okay, so if yours is a negative, go ahead and make it positive. So I'm going to put positive 1/3 in a box, and I'm going to write out all my coefficients. So I have a 3, I have a negative 1, I have negative 15, and I have 5. Okay. When I bring my 3 down, 3 times 1/3. Now, if you're not good with fractions, just write it out. So if I do 1/3 times 3 over 1, notice my 3's cancel, and I just get 1. Okay. So I put 1 up here. Negative 1 and 1 is 0. Okay. 0 times 1/3 is 0. And when I combine down, I get negative 15. Again, if you're not good with fractions, write it out. 1/3 times negative 15 over 1. 3 goes into 15 5 times. So 1 times negative 5 gives me negative 5, which is 0, right? Which is what we wanted. We needed it to be a 0, right? Because they told us it's a 0, so hopefully we have a 0 remainder. Okay, and then this is our 1's unit, or our constant term. This is our x. This is our x squared. So what we're left with, if I wanted to write this function out, f of x is the same as the 0 that they gave us, which would have been x minus 1/3, times the remaining factor that we just found, which is 3x squared minus 15. Okay, we already have the 0 from this factor, which is 1/3. So now we just need to solve this remaining factor. So 3x squared minus 15 equals 0. I move my 15 to the other side. So 3x squared equals 15. I divide off my 3, which gives me x squared is equal to 5. And then again, I just take the square root of both sides. Don't forget your plus or minus. So I hit x equals plus or minus the square root of 5. If it's not a perfect square and it's not a radical that can simplify, just leave it like this. Okay, don't give me a decimal or anything like that. So that means the zeros of this f function are positive 1/3, the square root of 5, and negative square root of 5. Okay? All right, so there's one for y'all to try. I'll give you a minute to work on it, and then we'll go over it. Okay, so on this one, they give us the 0 of negative 5. So we do synthetic with negative 5, which leaves us with the polynomial x squared minus 2. Okay, so if I wanted to write out this f of x function, we already have the factor x plus 5, which we know if we solve that, we get the negative 5 they gave us. The remaining factor that we got by doing synthetic was x squared minus 2. So I just need to solve this one to see what my remaining zeros are. Okay, I move my 2 over, which makes it positive. Take the square root of both sides. Don't forget plus or minus, which means that my remaining zeros are positive and negative square root of 2. Okay, all right. So now what we want to do is we want to move on to where they give us a polynomial function and we find all of the zeros without them giving us one as a starting point. Okay, so in order to do that, we are going to use the Rational Zero Theorem. Okay, but before I go over that, I just want to mention the Conjugate Roots Theorem. That means if we have some polynomial function, this is just the standard form of a polynomial function, okay, and it has only real coefficients, so no weird complex coefficients, if the complex number a plus bi is a zero of this function, then so is the complex number a minus bi. In terms of the linear factors of f, that means that if x minus a plus bi is a factor of f, then so is x minus a minus bi. Now, that's a whole lot of math mumbo jumbo, right? But the whole idea of it is that zeros with i's show up in conjugate pairs. Okay, so I'm just going to put zeros with i's, or with imaginary numbers, show up in conjugate pairs. So what that means, if I have an example, that means if negative 2i is a 0, then positive 2i is a 0. Okay? If 4 minus 3i is a 0, then 4 plus 3i is a 0. Okay? So that helps us a little bit. If we figure out one of our zeros and it's complex, then we know its conjugate pair, meaning the exact same factor, but we change the I term, will also be a 0. Okay? And in terms of the factors, this would mean that if x plus 2i is a factor, then x minus 2i is a factor. Okay? And the same thing with the second one. If I have x minus 4 plus 3i is a factor, then x minus 4 minus 3i is a factor. Okay? So they show up in conjugate pairs. All right, so keeping that in mind, now we want to look at the Rational Zero Theorem, which says if we have a polynomial function, excuse me, where, and they wrote out our general polynomial, okay? Any rational zero of f, rational meaning it can be written as a fraction, okay, must be of the form p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. Okay, so I'm going to go ahead and just highlight this. Okay, p is a factor of the constant term. Okay, the constant term in this case is a naught. Okay, whatever that constant term is, that's what we're calling p. Okay, and then q is the factor of a leading coefficient. So remember, the leading coefficient is this first a sub n number part of the highest degree term. So all we have to do is look at our leading coefficient and our constant term, and we just divide their factors, and that tells us all the potential rational zeros, okay, or all the possible ones. So I want to point this out. This theorem finds all the potential rational zeros. So we're going to come up with a list, which a list is still better than saying anything could be a zero. It narrows it down from all possible numbers down to a small list. However, the small list, not every single number in this list will actually be a zero. It just helps us narrow it down. So it's just the potential zeros, okay? Now, once we find a zero that works, once we find one little zero that works, then we can work it like we did all those other ones. Once we know one zero, we use the zero we know was synthetic to find the remaining. Okay, so let me show you how we use this theorem. So the factors of q, I'm going to go ahead and put, this is the factors of the leading coefficient, okay, on bottom. And we put the factors of our constant on top. Factors of the constant go on top, okay? And notice there's plus or minus, because if 2 is a factor of something, then negative 2 would be a factor of something. So instead of having to write out all our factors positive and all our factors negative, we're just going to use plus or minus and then list the numbers so we don't have to write them twice. Okay, so if I look at this first one, okay, the leading coefficient, remember, is my q. My constant is the p. So if I want to find, excuse me, all potential factors, I'm doing plus or minus, okay, all the factors of my constant, so factors of 8, divided by all the factors of my leading coefficient. So that would be the factors of 3. Okay, so I'm just going to write this out. Plus or minus everything that goes, oh, my squiggly brackets are ugly today. So everything that goes into 8. 1 goes into 8, 2 goes into 8, 4 goes into 8, and 8 goes into 8. On the bottom, all the factors of 3. 1 goes into 3, 3 goes into 3. Okay, so now that we have it written out like this, what I want to actually do is go ahead and write out all the possible ones. I don't want to leave it in this form. I'm going to take every factor on top and divide it by every factor on bottom. So this gives me plus or minus. If I do 1 divided by 1, I get 1. 1 divided by 3, I get 1/3. Okay, 2 divided by 1, I get 2. 2 divided by 3, I get 2/3. 4 divided by 1 gives me 4. 4 divided by 3 gives me 4/3. 8 divided by 1 gives me 8. And 8 divided by 3 gives me 8/3. Don't give me decimals, just leave them as fractions. Okay, just make sure they're reduced fractions. So for this function, these are all the potential zeros. Okay, so I'm not actually finding the actual zeros. I'm just looking for the possible ones. Okay, let's do it one more time, and then we'll look at putting this all together. So again, we do all the factors of the constant term, okay, which is our p, and divide it by all the factors of our leading coefficient, which is our q. So here p over q is the same as plus or minus. We're going to do the factors of 15 divided by the factors of 2. Okay, factors. So that gives me plus or minus everything that goes into 15 would be 1, 3, 5, and 15 divided by all the factors of 2, which would just be 1 and 2. Okay. So when I write out all the possible ones, dividing these out, 1 divided by 1 is 1. 1 divided by 2 is 1/2. 3 divided by 1 is 3. 3 divided by 2 is 3/2. 5 divided by 1 is 5, and 5 divided by 2 is 5/2. 15 divided by 1 is 15, and 15 divided by 2 is 15/2. So these are all of our potential zeros. Okay, so once we find our potential zeros, what we're doing now is we're just going to start plugging them in using synthetic division. Okay, doesn't matter which ones you pick. I try to pick the ones that I think would be easiest to do synthetic division with. But we just keep doing synthetic division until we get a zero remainder. Once we get a zero remainder, we know that that one is actually a zero of the function, and it's also a factor, right? So once we have one that works, then we can find the remaining factor and find the zeros from it. So that's what we're going to do here on the next page. So it says, list all potential rational zeros of the following polynomials. Use polynomial division and the quadratic formula, if necessary, to identify the actual zeros. Then write the function as a product of linear factors. So once we know all the zeros, then we can just move them back across the equal sign like we did at the beginning of the section and write them as factors. Okay? So let's go ahead and write out all the potential zeros. So if I want to look at the potential zeros, I'm going to do plus or minus the factors of my constant term. So here I'm going to do the factors of 24 divided by the factors of my leading coefficient, which here is 1. Okay, so I have plus or minus. Now, the only factors of 1 that I have is 1, right? Plus or minus 1. So if I take all the factors of 24 and divide them all by 1, I end up with just all the factors of 24. So I'm not going to write it as a fraction. I'm just going to go ahead and write out all the factors of 24, which would be 1, 2, 3, 4, 6, 8, 12, and 24. Okay, so these are all my potential zeros. Excuse me, potential rational zeros. And now I want to start plugging them in using synthetic division until I find one that works. So I'm going to start with positive 1. Why not? So I put positive 1 in my box and I write out my coefficients. Now notice I'm missing an x cubed and an x term, so make sure you put zeros in. So I have 1, 0, negative 10, 0, 24. So I bring down my 1. 1 times 1 is 1. 0 and 1 is 1. 1 times the 1 in my box is 1. Combined down, I get negative 9. Negative 9 times 1 is negative 9. I combine down, I get negative 9. Negative 9 times 1 is negative 9, which here is not going to equal 0. Okay, so this one doesn't work. So let's try another one. Let's try, excuse me, -1. If I do -1, I have 1, 0, -10, 0, and 24. Draw my line. Bring my 1 down. 1 times -1 is -1. 0 and -1 is -1. -1 times the -1 in my box is +1. I combine down, I get -9. -9 times -1 is +9. And I combine with 0, I still get +9. +9 and -1 is -9, which notice again, 24 minus 9 is not going to give me a 0 remainder. So I mark that one out. Let's look at another one. Let's try, we did plus or minus 1, let's try 2. Excuse me. So when I try 2, write out my coefficients, 1, 0, -10, 0, 24. Bring my 1 down. 1 times 2 is 2. 2 and 0 is 2. 2 times the 2 in my box is 4. When I combine down, I get -6. Times the 2 in my box is -12. Combine down, I get -12. Times the 2 in my box is -24. So I got a 0. Yay, there's great rejoicing. Okay, so once I get a 0, I'm just going to say yay. When I get a 0, I know that this number is a 0. Okay, so I want to go ahead and write it as a factor. So that means my original f of x is equal to, if x equals 2 as a factor, then that means if x equals 2 as a 0, then that means x minus 2 was a factor. The remaining factor, remember, is what I'm left with when I did my synthetic. So remember, this is my constant term. This is my x term, my x squared, and my x cubed. So what I'm left with is x cubed plus 2x squared minus 6x minus 12. Okay, so now all I need to do, I already have this one. I have that x is equal to 2. I put it in my little purple spiky circle over here. So now I need to factor this remaining one. Since I have 4 terms, I'm going to try grouping. So when I group, I can take an x squared out of the first pairing, which leaves me with x plus 2. And if I want to be left with x plus 2 over here, I need to take out a -6. Okay. Oh, excuse me. Okay, so when I take out x plus 2 and x plus 2, that leaves me with x plus 2 times x squared minus 6. And then I can go ahead and solve these. Okay, so x plus 2 equals 0 and x squared minus 6 equals 0. Okay, so when I solve the first one, I get x equals -2. When I solve the second one, I get x squared equals 6. And then I take the square root, which gives me x is equal to plus or minus the square root of 6. So that means that the actual zeros are the purple one I have in the spiky circle, so 2. The other ones I found from my remaining factors, which would be -2, positive square root of 6, and negative square root of 6. Okay. And then the last thing it asked me to do is go ahead and write out my f of x in factored form. So I'm going to say f of x is the same thing as, all I have to do is take each of these zeros and move it back across the equal sign. So I would have x minus 2 times x plus 2 times x minus the square root of 6 times x plus the square root of 6. And I'm going to leave it like that. Now in your homework, I can't remember if it will let you leave it as x squared minus 6 or if you have to go ahead and break it all the way down into the square roots. I prefer that you break it all the way down, but in my math lab, it may let you leave it as x squared minus 6. You'll just have to look. Okay, sorry. Let me look at another one. So again, we find all the potential factors. We start plugging them in until we find, potential zeros. We start plugging them in until we find one that works. Once we find one that works, then we just take that bottom factor from our synthetic under the line and go ahead and factor it or use quadratic formula or whatever needs be to find the remaining zeros. Then once we have all the zeros, we can write them all as factors and write the function as a factored function. Okay, so let's look at one more. I say one more. I'm actually going to look at 2 more. Okay, first thing I want to do is find the potential zeros. Okay, whoops. me spell potential right. Potential zeros. So I'm doing plus or minus the factors of my constant term. So I'm going to put here factors of 30. And it could be negative 30 or it could be positive. Doesn't matter. 30 and negative 30 have the same factors. All over the factors of my leading coefficient, which here is 2. So this one I'm going to write out because it might simplify a little bit. So I'm going to do plus or minus everything that goes into 30 would be 1, 2, 3, 5, 6, 10, 15, and 30. All over the factors of 2, so 1 and 2. Now I'm going to simplify this a little bit, plus or minus, by writing them all out. 1 divided by 1 is 1. 1 divided by 2 is 1/2. 2 divided by 1 is 2. 2 divided by 2 is 1, which notice we already have, so we don't have to list repeats. So I move on. 3 divided by 1 is 3. 3 divided by 2 is 3/2. 5 divided by 1 is 5. 5 divided by 2 is 5/2. 6 divided by 1 is 6. 6 divided by 2 is 3, which we already have. Okay. 10 divided by 1 is 10. 10 divided by 2 is 5, which we already have. 15 divided by 1 is 15. 15 divided by 2 is 15/2. 30 divided by 1 is 30. And 30 divided by 2 is 15, which we already have. Okay. So these are all my potential zeros. Hopefully we don't have to plug all those in. Okay, sorry I ran out of room a little bit. So now that we have all of our potential zeros, we're just going to start plugging them in with synthetic. So I'm going to go ahead and plug in. I always start with 1. Why not? And then I'm going to write out my coefficients. I'm not missing any terms. So I have a -2, 11, 1, -30. I bring my -2 down. -2 times 1 in my box is -2. 11 minus 2 is 9. 9 times the 1 in my box is 9. Combined down I get 10. 10 times 1 is 10. This is not going to give me a 0, right? So let's go ahead and look at -1. If I put -1 in my box, -2, 11, 1, and -30. Bring down my 2. -2 times -1 is +2. Combined down I get 13. 13 times -1 is -13. Combined down I get -12. -12 times -1 gives me +12, which is not going to give me a 0, right? Hopefully I'll get a 0. Let's look at 2. When I plug 2 in, -2, 11, 1, -30. Bring my -2 down. -2 times 2 is -4. 11 minus 4 is 7. 7 times 2 is 14. Combined down I get 15. Times the 2 in my box is +30, which does give me a 0. Yay! Okay, so if that gave me a 0, then that means +2 is one of my zeros. So I'm going to go ahead and write this out. So my f of x function is equal to, since 2 is a 0, that means x minus 2 is a factor, times my remaining factor down here, which remember 15 is now my constant term, 7 is my x term, and -2 is my x squared term. So I get -2x squared plus 7x plus 15. Okay, so all I have to do is find the remaining factors of that purple piece. Okay, so to do that, I'm going to go ahead and try sum product, see if it's factorable. If it's not factorable, then I'm going to have to do the quadratic formula. So to do sum product, I need a sum, which is always my middle coefficient of 7, and my product, which is my leading coefficient, times my constant. So -2 times 15 is -30. So something that multiplies to -30 that I can combine to 7 would be 10 and -3, right? 10 and -3 multiplied give me -30, and 10 minus 3 gives me 7. Now my leading coefficient is not a 1. When my leading coefficient is not a 1, I take this pair of terms and I replace my middle term so that I can group. So I'm going to do -2x squared plus 10x minus 3x plus 15, and then group. Okay. Again, if you know how to factor this using trial and error, I'm fine with that. I'm going to go ahead and factor out a common factor, which here would be -2x, which leaves me with x minus 5. If if I want to be left with x minus 5 over here, then I need to take out a negative 3. And now that both terms have x minus 5, when I take that out, I'm left with negative 2x minus 3. Okay? And then I'm going to go ahead and bring down this other factor, x minus 2. Okay? So now I have f of x factored. I just need to solve each factor. The first one we've already solved. That's the purple that I got in my spiky circle. So I need to say x minus 5 equals 0, which gives me x equals 5. And I need to do negative 2x minus 3 equals 0, which gives me negative 2x equals positive 3, and then I divide off my negative 2, which gives me negative 3 halves. Okay, which means that my actual zeros are the 2 that I got in my fiery purple circle there, the 5 and the negative 3 halves from the remaining factor. Okay. And then I want to go ahead and write out f of x completely factored. Now it is completely factored here, but I will point out one thing. Anytime you have two terms that are both negative, my math lab sees that as a negative and they always factor it out. I don't think it'll count you wrong if you enter it like this, but it's good form that anytime both terms or all three terms or however many terms there are, if they're all negative, we always factor that out and put it at the front. So I'm going to put my negative out here, and then x minus 2, x minus 5, and then this term is now positive 2x plus 3. Okay, so that's what it looks like completely factored. Okay, all right, let me look at one more, and then I'll have y'all try one. So first thing we do is look for our potential zeros. When we look for potential zeros, we write all the factors of our constant. Potential zeros. Wow. Mrs. Williams can't write. Zeros. So we're going to do plus or minus the factors of 13 over the factors of my leading coefficient, which is 1. Now again, the only thing that goes into 1 is 1. So basically my potential factors are just going to be the factors of 13. Okay? The factors of 13 here are just 1 and 13. So those are my potential ones. So I'm going to start plugging those in until I find one. So again, I start with positive 1. You can start with whatever number you want, but 1 is my starting point out of habit. Okay, I'm not missing any terms, so I write out my coefficients: 1, negative 3, 9, and 13. I bring my 1 down, which is just 1. 1 times 1 is 1. Combine down, I get negative 2. Negative 2 times the 1 in my box is negative 2. I get 7. 7 times 1 is 7. That is not going to equal 0. Let's look at negative 1. Negative 1, I have 1, negative 3, 9, 13. Bring my 1 down. 1 times the negative 1 in my box is negative 1. I combine down, I get negative 4. Negative 4 times the 1 in my box is positive 4. Combine down, I get 13. 13 times the negative 1 in my box is negative 13, and I get 0. Yay! So that means that this one is a 0. So I know that negative 1 is a 0. So I'm going to go ahead and write this out as it looks. So f of x is equal to, since negative 1 is a 0, we know that x plus 1 is a factor, times my remaining factor here, which remember, this is my constant, this is my x, this is my x squared. So I'm left with x squared minus 4x plus 13. Okay. So I just need to factor this last one to see what I end up with. So notice, if I want to do sum product, I need something that combines to negative 4 that multiplies to 13. And the only thing I can get to multiply 13 is 1 and 13. And that doesn't work to combine to negative 4. So this one's not factorable, so I'm going to use the quadratic formula. Okay, so the quadratic formula, remember, is x is equal to negative b plus or minus the square root, the square root of b squared minus 4ac all over 2a. So when I plug mine in, negative b, I have a negative 4, so that will become positive 4, plus or minus the square root of b squared, so negative 4 squared, which is 16, minus 4 times my a, which is 1, times my c, which is 13, all over 2 times my a, which is 1. Okay? And then I just simplify. So I get 4 plus or minus 16. When I multiply 4, 1, and 13 together, I get 52. Since there's a negative there, this is going to be negative 52 all over 2. Okay. So I have x is equal to 4 plus or minus the square root of negative 36 all over 2. Remember, anytime you have a negative underneath the radical, it comes out as an I. So I have x is equal to 4 plus or minus 6i all over 2. And then I'm just going to reduce it by breaking it apart. Okay, if I put each piece over 2, I can reduce. So I get x is equal to 2 plus or minus 3i. So now I know my actual zeros. Actual zeros. Oh my goodness. My hand is not doing what my brain's telling it to. Actual zeros would be the one that we found in purple here with the big spiky circle around it, which was negative 1. And then we got 2 plus 3i and 2 minus 3i. Okay. And then the last thing we need to do is write this out in factored form. So remember, we had f of x is equal to x plus 1, which is the one we got from our 0 in synthetic. And then we didn't factor the other piece. The other piece we had to use quadratic formula. So to write those as factors, we just move them back across the equal sign. In other words, if I have x is equal to 2 plus 3i, I'm going to move the 2 back over and the 3 back over, which would give me x minus 2 minus 3i. Okay. When I do the same thing for the second factor, I get x minus 2 plus 3i. Okay. And remember, our conjugate roots theorem said that if you have a complex 0, its conjugate pair is also a 0. Okay, so it says, notice here the conjugate zeros. This is the conjugate of this one, and notice we also have conjugate factors. So you know you've done something wrong if you end up with an I in an answer, but you only have one. Okay, they always show up in conjugate pairs, meaning they look identical, except the sign of the I term is opposite. So there are 3 here for you to try. I'll give you some time to work on them, and then we'll go over them. Okay? All right, so on this first one, notice we find all of our potential zeros first, which is all the factors of 15 divided by all the factors of 2. So I have 1, 3, 5, 15 all over 1 and 2. Always write them out as every possible 0. Don't leave them as a fraction of numbers over a fraction over another list of numbers. Okay, so your potential should be 1, 1/2, 3, 3/2, 5, 5/2, 15, and 15/2. We start plugging those in, right away we get 1 to work. So that's awesome. So we have x minus 1 as a factor, because that's a 0 we got to work. And our remaining factor would be 2x squared plus 11x plus 15, which we need to go ahead and solve for the zeros. You can use quadratic formula, or this one is factorable. So I went ahead and used sum product. I need something that combines to 11 that multiplies to 30, which here would be 5 and 6. So I replaced my middle term because my leading coefficient wasn't a 1. We can use our shortcut. And then did grouping. Okay, once I group, I ended up with 2x plus 5 as a factor and x plus 3 as a factor. So when I set each of those equal to 0 and solve, I end up with negative 5/2 and negative 3. Okay, so these are my actual zeros. And then right below it, I went ahead and wrote the function out in factored form. So my first factor came from the 1 from my synthetic, so that's a factor of x minus 1. And then since I solved the other piece by factoring, I already know those factors are 2x plus 5 and x plus 3. Okay, let's look at the next one. Number 2, our potentials, we solve for all the factors of 50 over 1. So pretty much just the factors of 50, which in this case are 1, 2, 5, 10, 25, and 50. So I plug in a 1, and y'all are getting lucky because 1 worked. Okay, 1 worked, and it left me with a factor of x to the 4th plus 2x cubed plus 25x. Oh wait, this is a typo. Hold on. I have the exponents wrong. It should be a 3 and a squared. Okay. So you're left with x cubed plus 2x squared plus 25x plus 50. And then you do grouping which gives you the remaining factors of x plus 25 and x plus 2. So I solve those two factors, which gives me a negative 25 and a negative 2. So that means my actual zeros are 1, negative 2, and negative 25. And then when I write it in factored form, I should have x minus 1 times x plus 25 times x plus 2. Okay, let's look at the last one. The last one, our potential zeros are all the factors of 3 divided by all the factors of 3. So on top I have 1 and 3, on bottom I have 1 and 3. So when I write them out, 1 divided by 1 is 1, 1 divided by 3 is 1/3, 3 divided by 1 is 3, and 3 divided by 3 is 1, which we already have, so we don't repeat it. So we start plugging these in. We didn't have to do much work at all. Every single one worked. All right, so we plug 1 in using synthetic, and we got a 0 remainder, which left us with a polynomial, excuse me, 3x cubed plus 3x squared plus 3x plus 3. And notice once I factor it, I'm left with 3x squared plus 3 plus x plus 1. Okay, so when I solve this one, I obviously get negative 1. So my zeros are plus and minus 1. And then when I solve 3x squared plus 3, I end up with plus or minus I. So my actual zeros are plus or minus 1 and plus or minus I. And my factored form is actually incorrect because I left off my 3. So I'm going to go ahead and say f of x is the same as 3 times this mess. Because notice, here I have it pretty much factored out, right? But since I want a factor for each one of my I terms, I took this and just moved it back across the equal sign to get these two factors. But since I had this 3 that I could factor out, I needed to make sure to put that out front. Okay, so if you choose to use that shortcut, make sure that there wasn't a greatest common factor that you could pull out. Okay, and if there is, make sure you include it in your factored form of the function. Okay. All right, so all I want to do is a couple more examples that are a little bit more advanced, and then I'll have y'all try one, and then you should be able to do your homework, okay? So let me scroll past these. We just went over them. Okay, so some more advanced examples. We're doing the exact same thing. Find the potential, use that to find the actual, write the function as a product of linear factors, okay? So the first thing I want to do is identify all my potential zeros. So potential zeros, which is plus or minus all the factors of 8 over all the factors of 1. So again, all the factors of 8, 1, 2, 4, and 8 over 1. So when I write each of those over 1, I'm just going to get 1, 2, 4, and 8. So these are my potential zeros. I want to start plugging them in until I find one that works. Okay, so I'm going to go ahead and plug in 1. When I plug in 1, I write out my coefficients, which is 1, 4, 1, negative 10, negative 4, and 8. I bring down my 1. 1 times 1 is 1, which gives me 5. 5 times 1 is 5, which gives me 6. 6 times 1 is 6, which gives me negative 4. Negative 4 times 1 is negative 4, which is negative 8. Negative 8 times 1 is negative 8, which gives me a 0. So yay, we got an easy one. Right off the bat, we know that 1 is a 0. Yay. And notice what we're left with is something we cannot factor, right? Because this is my constant term, this is my x, this is my x squared, this is my x cubed, and this is my x to the 4th. We only know how to do 3-term polynomials using quadratic formula or sum product. And we know how to do 4-term polynomials by grouping. But we have no way of doing 5-term polynomials. So what I'm going to do is, instead of starting with my original function, I'm going to take my other factor here and keep going with synthetic. So I'm going to go ahead and write down now what I have is f of x is the same as the factor that we just found, which would be x minus 1, times this remaining factor, which is x to the 4th plus 5x cubed plus 6x squared minus 4x minus 8. Okay. So I'm going to keep going with synthetic using this factor. So notice all my potentials of it still has a constant of 8 and a leading coefficient of 1. So I'm going to keep plugging in using my original potential zeros. And I'm going to look at, let's see, we already plugged in 1, so let's try -1. So if I do -1, and again, I'm using my purple numbers, remember. So I'm doing 1, 5, 6, -4, -8. Okay. I bring down my 1, which is 1. 1 times -1 is -1, which gives me 4. 4 times -1 is -4, which gives me 2. 2 times -1 is -2, which gives me -6. -6 times -1 is +6, so that one did not work. Let's look at 2. If I look at 2, again, I'm using my purple numbers, not the original. So 1, 5, 6, -4, -8. I'm going to go ahead and do synthetic. So I bring down my 1. 1 times 2 is 2, which gives me 7. 7 times 2 is 14, which gives me 20. 20 times 2 is 40, which gives me 36. 36 times 2 is 72, so that one's not going to work either. So what have we done? 1, -1, 2. Let's try -2. -2. Again, I'm still plugging these into my purple. 1, 5, 6, -4, -8. Every time we find something that works with synthetic, we're breaking down the original a little bit more. So here, the reason I'm using the purple one is since we've already broken one factor off, I'm trying to break the purple down more. Okay, so if I can break it down more, then maybe what I'm left with will be something that I can actually factor at this point. Okay, so I bring my 1 down. 1 times -2 is -2. I combine down, I get 3. 3 times -2 is -6, which gives me 0. 0 times -2 is 0, which gives me -4. -2 times -4 is +8, which gives me a 0. Yay! Yay! I just realized my other yay looks like gay. So I'm going to rewrite that so that it doesn't look like it's saying gay. Yay. There we go. That's better. Okay. So now that we found something that it broke down further to, I'm going to go ahead and write the factors that I have now. Okay. So now I know -2 is also a 0. So now my function looks like f of x is equal to that first purple 0 that I got, which was x minus 1 as a factor, and now this -2 that I got here in my blue pokey circle, which would be a factor of x plus 2, times my remaining factor here in blue. Remember, this is my constant, this is my x squared, and this is my x cubed. So I'm left with x cubed plus 3x squared minus 4. Okay. All right, now we have another problem. I would love to just say, okay, let's factor what's left in blue, but we don't have any rules for factoring a 3-term polynomial that's missing an x term, right? An x cubed, as you look down here at the bottom of our synthetic, normally has 4 terms, and 4 terms we would use grouping. Well, we can't use grouping here, so we're going to have to keep going again with synthetic. But since we've already got 2 factors out there, I want to go ahead and look at this blue factor and break it down, again continuing with synthetic. Now, one thing I will point out is I'm not going to start plugging in all my originals because look, now my constant term is a 4. So if I wanted to find my potential zeros of just this little blue piece, it's going to be the factors of 4, which is just 1, 2, and 4. Okay, so I'm going to go ahead and plug in 4 and -4 because those are ones we haven't plugged in. Hopefully one of them will work. If one of them doesn't work, then that means we might have a repeat of one of the factors or one of the zeros that we've already gotten. Okay, so I'm going to keep going with synthetic, and I'm going to go ahead and try 4. And this time I'm continuing on with my blue numbers, which would be 1, 3. I don't have an x term, so 0 and -4. I draw my line, bring my first one down. 1 times 4 is 4, which gives me 7. 7 times 4 is 28, which gives me 28. 28 times 4 is not going to give me a 0, so that one doesn't work. Let's look at, excuse me, let's look at -4. Okay, if I plug -4 in using my blue numbers, I have 1, 3, 0, 4. So I draw my line. So I bring this down, which is 1. 1 times negative 4 is negative 4. I combine down, I get negative 1. Negative 1 times negative 4 is positive 4, which gives me 4. And 4 times negative 4 is negative 16, which does not give me a 0. So here, again, if I look at the constant term here, it's 4. The only thing that goes into 4 is 1, 2, and 4. So I've tried both 4s and it doesn't work. So it may be that I have a repeat of one of the zeros that I've already come across. So let's try 1 again. Okay, it is possible to have more than one copy, just like we talked about with the multiplicity and that type of thing in the last couple of sections. Okay, we may have a factor that's repeated. So if we try 1, let's go ahead and write out our blue numbers, which is 1, 3, 0, negative 4. So I bring down my 1, which is 1. 1 times 1 is 1, combine down I get 4. 4 times 1 is 4, combine down I get 4. 4 times 1 is 4, combine down I get 0. Yay, we got something that works. So notice here we got another 0, which is positive 1, which is one we've already gotten, but we have to account for the repeat. Okay, yay. And now I want to factor, see if I can factor what's left over. Okay, this is my constant, this is my x, this is my x squared. So I'm going to go ahead and write out, what my what my function looks like. My original 0 that I found with my purple synthetic here was x minus 1 times the 0 I found with my blue synthetic, which was negative 2, so that gives me x plus 2, times the pink 0 that I just found, which is 1, which gives me another factor of x minus 1, times the remaining factor I have down here, which is x squared plus 4x plus 4. Okay, so now I just need to factor this remaining one. Factor, and hopefully we can use sum product. Our sum is 4, our product is 4, which we can use 2 and 2. So this one factors into x plus 2 times x plus 2, which notice these are the exact same. So when I solve it, x plus 2 equals 0. That gives me negative 2, okay, which is another 0. So notice of all the zeros, I have a negative 2 here, I have a 1 here, I have a 1 in purple, and I have a negative 2 in blue. So really, the only actual zeros that we're getting are positive 1 and negative 2. Okay. Now, when I write out my factored version of this function, I need to account for all the copies of each of these factors we have. Okay, so notice my x minus 1s, I had 1 here and 1 here. So I have 2 of those. And then of my x plus 2s, I had 1 here. And then when I factored this pink piece, I got 2 more of them. Okay, so I ended up with 3 of those factors. So completely factored, this function looks like the quantity x minus 1 squared times the quantity x plus 2 cubed. Okay. So this one was a little bit different in that there wasn't a point where we just found 1 0 and then, oh, we factored what was left over. Okay, if we can't factor what's left over, we just continue with synthetic and we continue breaking it down. If we break it down again and we can't simplify, we continue with synthetic until finally we can simplify what's left over. Okay, let me look at one more and then I'll have y'all try one. Okay. So this one again, I can't factor this right off the bat, right? Because if I tried grouping, I'm one term short. So I'm going to go ahead and find all my potential zeros, which is going to be plus or minus all the factors of 10 over all the factors of 1. So pretty much just all the factors of 10, which is 1, 2, 5, and 10. Okay. So here are my potential zeros. Now I'm going to start plugging them in until I find one that works. So I'm going to go ahead and plug in a 1. When I plug in a 1, I have 1, 1, 3, 5, negative 10. Bring down my 1. 1 times 1 is 1, which combines to 2. 2 times 1 is 2, which combines to 5. 5 times 1 is 5, which gives me a 10. 10 times 1 is 10, which gives me a 0. So that's good. That wasn't too bad. So I'm going to go ahead and say here, yay, we found one that works. So 1 works. So I'm going to go ahead and rewrite my function in factored form. So f of x is equal to the factor I get from this 0, which would be x minus 1, times the remaining factor here. So 10 is my constant, 5 is my x, 2 is my x squared, 1 is my x cubed. So I'm going to get 1 x cubed plus 2x squared plus 5x plus 10. Okay. And then I want to see if I can factor this. Now, anytime I have 4 terms, I always want to try grouping. If grouping doesn't work, then I'll have to continue with synthetic. Okay. So I look at my pairings. Here I can pull out an x squared, which leaves me with x plus 2. If I want to be left with x plus 2 over here, it is possible I have to take out a 5. So then I can take out my x plus 2 quantity, which leaves me with x squared plus 5. Okay. So again, I'm just going to go ahead and rewrite out here what I have. Okay. This one I already have. I need to solve these other two. So x plus 2 equals 0, x squared plus 5 equals 0. So I end up with x equals negative 2 when I move my 2 over, and I get x squared equals negative 5, which when I take the square root, I get plus or minus the square root of negative 5, which is equal to plus or minus I root 5. Okay, or if you want to write it as 5 plus or minus square root of 5i, that's fine. Just make sure the I is not underneath the little radical. Okay. All right. So this means that my actual zeros are the purple one I got in the spiky circle, which was 1, and then my negative 2 from my remaining factor, and then my positive I root 5 and my negative I root 5. Okay. So these are all my zeros, and then I want to write my function completely factored. So I had x minus 1. If I were to move that negative 2 back over, I get x plus 2, and then I have x minus I root 5, and x plus I root 5. Okay. Not too bad. Okay, so there's one on the next page for y'all to try, and we'll go over it in just a second. All right, so on this last practice problem, the first thing I do is find my potential zeros. So factors of the constant, which is negative 5, over factors of the leading coefficient, which is 1, which means the only potential zeros I got is 1 and 5, plus or minus 1 and 5. So when I plug 1 in, that works. So that means that my function is the same as x minus 1 times my remaining factor, which here is x squared minus 4x plus 5. Okay, I want to factor that remaining piece, but I can't do it with some product. It's not possible. So I have to use a quadratic formula. When I plug in my a, b, and c into the quadratic formula, I get down to getting x equals 2 plus or minus I. Okay, which means my actual zeros are the 1 that I got from synthetic, and then 2 plus I and 2 minus I. When I write this in factored form, I take my solutions from the quadratic formula and move them back across the equal sign, which gives me x minus 2 minus I and x minus 2 plus I, and then the factor that I got from my synthetic, which was x minus 1. Okay, so finding potential zeros, and then we take that list of potentials, start plugging them in using synthetic until we find one that works. And then once we find one that works, we look at our remaining factor that's underneath the line and try to factor it. If it factors it, great, we're done. If it doesn't, we continue with synthetic until we find all of our actual zeros. Once we find all of our actual zeros, then we write the original function in factored form. Okay? All right, so that is the end of 3.3. You can now do the 3.3 assignment on My Math Lab. There is also a worksheet that is listed under your worksheet tab, which is under your course materials tab for 119. Okay, this worksheet is called E3.1 through E3.3 worksheet. Okay, so you should now be able to do that paper worksheet, which you'll need to complete by hand and scan and email to me, as well as the My Math Lab assignment for E3.3. Okay, if you have any questions, please let me know. Good luck.